One form of animal cooperation is the support one individual gives another in conflict. This form of cooperation has been described as coalition formation. In this study, we focus on agonistic coalitions in which a third party takes sides in an ongoing dispute. For example, animal 1 and 2 might be having an agonistic conflict, and a third party, the joiner, might take animal 1's side by aggressing against animal 2. We would then call animal 1 the recipient of the coalition and animal 2 the opponent. Coalitions like these have been described especially often in despotic primates, in which agonism is frequent and social rank predicts fitness. We studied coalitions in a primate species in which agonism and coalitions are rare and rank does not predict fitness. We addressed two main research questions. How are members of different age-sex classes involved in coalitions? And when an animal joins in to form a coalition, which of the original contestants does it choose to support? Our study groups were located in the Kakamega Forest in Kenya, where they are part of a long-term study. I want to take this moment to thank all of the sponsors and field assistants who have enabled this work. In this study, we used data from ad libitum records of all group members and focal follows of adult females that spanned 12 years and 12 different groups. From this set of agonistic interactions, we extracted all cases of coalitions. Roughly half of these records, a total of 1497, were cases in which we observed and identified the joiner as it became involved and supported one of the original contestants to form a coalition. Just as a point of reference, these coalitions are very rare. Only 1.8% of all agonistic encounters led to the formation of coalitions. So how are members of different age classes involved? We compared observed versus expected frequencies. The expected values were based on the presence of different age classes in the study groups, which were monitored on a near daily basis. Looking at the graph to the upper right, we found that joiners were disproportionately adult females, whereas juveniles and infants were joiners less often than expected. On the bottom right, we can see that juveniles were disproportionately recipients. Everyone else was a recipient less often than expected. And looking at the graph on the bottom left, we can see that opponents were disproportionately adult males. Juveniles were seldom opponents. Now to our second question. Which contestant did the joiner support? To answer this question, we randomly assigned one of the original contestants as animal 1. We then used a logistic mixed effects model to evaluate variables that predicted whether or not the joiner chose animal 1. The variables we examined were: was animal 1 winning the original contest? Was animal 1 smaller than animal 2? What was the age class of both animal 1 and animal 2? And finally, how much more closely was the joiner related to animal 1 versus animal 2? Maternal relatedness was known from the long-term study of this population. Our best fit model also included an interaction between the age class of animal 1 and the relatedness variable. These graphs show how the probability of choosing animal 1 varies with predictors. The plot on the upper left is based on the success of animal 1 in its original dyadic agonistic encounter before the joiner joins in. So, was animal 1 winning or losing? We found that the probability of choosing animal 1 was lowest when it was losing, highest when it was winning, and intermediate when the outcome of the original dyadic interaction was unclear. The plot on the upper right shows that the probability of choosing animal 1 was lowest when animal 1 was bigger than animal 2, but increased when the two contestants were the same size, or animal 1 was smaller than animal 2. The plot on the bottom left shows that the likelihood of the joiner choosing animal 1 was highest if the opponent, animal 2, was an adult male, and quite a bit lower if the opponent was an adult female or large juvenile. The probability continued to decline for younger age classes. The abbreviations here stand for large juvenile, medium juvenile, and small juvenile, respectively. Finally, the plot on the bottom right shows the interaction effect. A value of 0 on the x-axis shows a situation in which the joiner is equally related to both of the original opponents. You can see that the chances of choosing animal 1 increase to the right, where the joiner is more closely related to animal 1 than to animal 2. To the left, where the joiner is more closely related to animal 2, the probability of choosing animal 1 is lower. However, the inflection point differs depending on the age class of animal 1. When animal 1 was a small juvenile, which is the yellow line furthest to the left, joiners supported them even when they were less closely related than animal 2 was. Infants, shown in the orange line second from the left, showed a similar pattern, though it was less extreme. Joiners supported older individuals only when the relatedness differential was considerably skewed in their favor. That brings us to our conclusions. In reference to our first research question, different age-sex classes participate in coalitions non-randomly, with adult females disproportionately forming coalitions in support of juveniles against adult males. In terms of our second question, blue monkeys seem to join coalitions in a self-serving way in that they prefer to support the winner, minimizing costs. They also prefer to support the more closely related contestant, maximizing inclusive fitness benefits. However, a preference for supporting smaller contestants, young individuals versus older ones, and smaller individuals even when they are less closely related, suggests that joiners also favor the most vulnerable individuals when all else is equal. Thank you so much, and I will now be open to take any questions.